Properly designed data centers do not use water, they don't demand nuclear power, and they don't scale uncontrollably. I'm going to take you through the underlying problem within our computation that's causing the problems with these data centers and the Infotton P30 update, which fixes the problem. So within our computers, we have bits and bytes. In every single byte, there are 8 bits. And these bits encode information in them. Now, when it's not just 8 bytes that get sent, it's 64, and every single time one of these bytes comes through, we go through a system called check bit systems to make sure that the information came through properly. Because information is a state of matter, and because it's a state of matter, that means that it's sensitive to manipulation, mutation, it has energy conservation, energy transfer, viscosity, density. And I'm showing you a demo here. So this is working software, and I'm showing you how we can encode or how the encoding works today on the Byte and compare it to the Infotton P30. So what we have here, and I'm going to just go a little bit faster, but every single time you send a piece of information, it goes through and actually checks that the information is proper. And these computations, I'm just going to accelerate this here a bit, every single one of them creates heat. Okay, so writing creates heat, reading creates heat. And this sentence alone performs 12,264 computations in this system. And you can see how these operations are producing heat. Because they're producing so much heat, they're demanding water. So I'm just going to go ahead, put a pause on this. I'm going to come over to the Infotton P30. So Infotton, this is most effective when it's put at the BIOS layer, but we can also do it at the encoding layer, just as a quick, push out, update, that type of thing, and then apply the update to the BIOS as necessary. Like, really, we want to get down to the BIOS layer. And so that means cooperation from IBM, NVIDIA, Microsoft, Apple, Intel, all of these big name players, the banks, right? Because our entire financial infrastructure is on this Byte-based system that IBM designed in 1964. So I think it's like 97% of the market, of the banking market, is on the Byte. Anyway, so inside of our numbers, we have in prime numbers, and prime numbers have a connection to quantum. They have a connection to entropy. So entropy, energy, heat, information, Rolf Landauer, 1961. So if we align our computation to these prime numbers, because within after 235, so 2 times 3 times 5 is 30. Once you reach 7, all the prime numbers fall in these same 8 columns, which means that we have natural architecture within our machines that makes them efficient and eliminates the need for checking for 73.3% of those errors. Okay, so let me show you here the difference between the BIOS. The BIOS only used 163 computations. Let me show it to you here at the encoding layer. And you'll see kind of a difference here. So these numbers, I mean, we've been teaching this methodology. It's been around since 1993. They teach it for sure at Cambridge. And it's just like, okay, let's just align our computers and let's just perform this update. And I have all the details in the patent for it. And because we're using less water, so I show you here, this is the Byte in the Infotton, okay? So at the BIOS level, the Infotton uses no water because it's not performing it's not emitting astronomical amounts of heat. It's not using astronomical amounts of energy like the current Byte infrastructure is. And because of that, the need for water gets eliminated. Data centers don't need water. They need a computer update. And because we eliminate, so over here, with these data centers is they get on this update, and this is all computers. This is data centers, our computers, our desktops, our tablets, our cell phones, our cameras, everything. But as we perform this update and we start to deploy it and scale, what that means is that we're no longer putting undue demand on the energy grid, and we can save over 21 gigawatts of power. Right? I mean, that's avoiding, just in this computer update alone, on the data centers, not even total for all the computations that we're performing, just one area, over 176 terawatt hours a year. And not having that much heat reduces the strain on the Great Salt Lake and makes it so that, these global thermodynamic events that are happening aren't impacting our very sensitive planetary benchmark system that we have, our Great Salt Lake. And then by returning water as well, by reversing that Bear River 1991, water grab, we can essentially meet half of the demand that's happening there. And most of that water is going towards alfalfa crops. Alfalfa is an invasive species from Iran that we export to China. Okay. So anyways, by performing this computer update, what we do is we essentially fix the entire system. It's not theoretical, right? I just showed you working software. We just have to get down to the next layer of the encoder and the BIOS. And we've done this before, right? So 1964, we set up the Byte architecture. We've had many different architectures from 4, 5, 8. So we've done this before, and then our last encoding layer was back in 1993, and that had the participation of IBM, Microsoft, Apple, Sun, Novell, Next. And so we just need our current players: NVIDIA, IBM, Microsoft, Apple, Intel, AMD, all these groups to come together. And by performing this computer update, like I said, properly designed data centers do not need water. They need a computer update. By performing this Infotton P30 update, we can essentially solve all of these problems that we've been having and, just really begin to advance humanity.